Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now we are focusing on some questions from our June and November 2024 paper. We are starting with May, June 2024, the first variant. And our focus will be on differentiation and integration. So let's look at the first question that is involving differentiation and integration. And yes, this is one question. This is called differentiation from first principle. They have hardly asked one or two questions since this thing is part of the syllabus. From 2020, differentiation from first principle is part of the syllabus. The equation of a curve is y is equals to fx. This is your fx. The following points lie on the curve. Non-exact values have been given correct to 5 decimal places. 1, 2, 3, 4, 5, like this. Find the value of k, give your answer correct to 5 decimal places. So where is k? K is right over here. That is the y coordinate of b. So the x coordinate is this. Just plug it in, evaluate, use a calculator, give the answer correct to 5 decimal places. This is basic arithmetic, basic numbers, nothing to do with differentiation as such. The table shows the gradient of the chords AB, AC, AD, AF. So that is AB, that is AC, that is AD, AE is not given, and AF is there. Find the gradient of the chord AE. So we have A, we have E. So now they are making us use to the gradient formula y2 minus y1 over x2 minus x1, and we get this thing. Now the last part, this has something to do with differentiation. What is this last part all about? So this last part is about something known as first principle, which simply says that if you are looking at the curve, and let's say if this is point A and this is B, C, D, E, if the points are very, very close enough, that part of the curve behaves like a straight line. So the value of gradient at that point is basically the value of this tangent. Got the idea? So now what they are saying is this. Deduce the value of f prime 2. So now the first thing that you need to realize is that they're asking us to deduce. Why? Because we cannot evaluate f prime x because it is a product of two functions of x. Where are the functions of x? There it is. This is something x, this is something x, this is a constant. Yes, you can ignore it because the derivative is 0, so we cannot evaluate the differentiation. Because product rule, and for that matter, quotient rule of differentiation is not part of the syllabus. This is not in P1. This is in P3. So yes, it's in P3, but it's not in P1. So that is why this cannot be done. So what do? The gradient of chord AB, since B is closest to A, that will give me the gradient. How do I know B is closest to A? Look over here. The x coordinate is 2. X coordinate of B is 2.001. Then 2.001. This is bigger. 2.01, even bigger. 2.1, very big. 3.11, very far away. So these two are the closest to one another, like this. So the gradient between these 2 points, which is already given over here, 6.2501, that is the value of the derivative at this point. Now, open your WhatsApp and let me write over here. That is the question of first principle. Is this thing, the last part, all good, all clear? Just put a tick mark over there. Again, let me emphasize it. This is called differentiation from first principle. Basically, you are evaluating the gradient without actually differentiating it. We cannot evaluate it because product rule, quotient rule of differentiation, if two things are multiplying together, how do you differentiate? That is not part of P1 syllabus. So what do? Out of all these points, you have to make a good choice. That good choice is, since B is closest to A, therefore gradient of AB will give the best estimate. It says there, gradient of the chord AB, since B is closest to A, xa is 2, f prime of 2 is 6.2501. That is the answer. So this is the gradient at A. That is why we chose AB, because we have AB, we have AC, AD, AE, AF. So this one was the closest. All good, all clear. So that is one question. Let's keep moving forward. And we are just focusing on differentiation and integration. And this looks like integration. Now, first thing is that when you look at integration question, don't be overwhelmed by it. They always come up with new type of equations. They always come up with new type of functions and so on. So just focus on the old concepts. That is the main thing. Got it? So now over here, the diagram is a bit weird. It's very much elongated. This is y is equals to 1. This is x is equals to 2.4. This is the curve right over here. That is this thing. Y is equals to this thing. You have to take it up. The power becomes negative. And all this information is given over here. That is the 0.11. And it says find the exact volume of the solid generated when the shaded region is rotated 360 degrees about the x-axis for 6 marks. Now, first of all, let me add a page over here and let me work on this thing. So now, first of all, what do we observe? We observe that this is 1, this is 2.4. Let me draw a line over here like this. And if I focus between these two lines, so what will I get? If I focus on y equals to 1, I'll get the volume of this rectangle, which will actually become a cylinder. So volume under the line, that is pi. The limits are 1 and 2.4. So this is 1, this is 2.4, this is 1 square dx. The concept is square whatever the equation is. Then after squaring, then integrate, then plug in the limits. Don't forget to multiply by pi. Now, if I focus on this thing, that is this curve, that is right over here. And if I find the volume under the curve, that is also 1, that is 2.4. Don't forget the pi. You have this equation, y is equals to 5x minus 4, 5x minus 4 raised to power of negative 1/3. Don't forget to square it dx. And then we are interested in volume between the two things. So line has more volume, curve has lesser volume. So we will subtract. I hope this is the principal thing. Now, let me focus on this one. That is, first decide the strategy. So first decide on the strategy. And once you have decided on the strategy, then proceed. Do not proceed without deciding on the strategy. Is it a simple volume? Is it a volume under two separate curves? Is it a volume between the two? So yes, it's between the two. Now you know how to do the integration. You know how to deal with the arithmetic part. You know how to plug in the limits over here, and then you get the answer. So now let's look at the answer. So have a good look at it. I want you people to have a good look at it. So this is volume between two graphs. So be vigilant and hold for a second. You can just have a look. Strategy, decision, and then execution. Got the idea? All working is very basic. Leave the answer in terms of pi, whether the examiner says it or not. First square, then integrate. And chain rule of integration is applicable. Increase the power by 1. Divide by the new power. Divide by the coefficient of x, even if it's as minor as 1. And then simplify. take these constants on the outside. And then this is 1 and 2.4. First plug in the upper limit, then plug in the lower limit. This is 0.6 pi. This is 1.4 pi. Beautiful answer by subtraction. That is 0.8 pi. So check your WhatsApp. If this is all good, all clear, just put a tick mark over there. Okay, जी आगे बढ़ते हैं. So now that thing is the strategy is done. And these were the two questions. No, I'm not focusing on circle. We will soon do so. The third question, that is again differentiation. And I think it's on 2 pages. So let me add the first page. And the second page is for later. No, I think there's also this page. My bad. Okay. So now let me just rearrange it. And like this. Okay. Now first have a good look at this question. So that is a function is defined by fx and this whole fx is given. X is not equal to 0 because that's like an asymptote. The graph of y is equals to fx is shown in the diagram. Find the set of values for which fx is decreasing. Decreasing means f prime x, let me write, f prime x is less than 0. That is what is meant by decreasing function. The second part, a triangle is bounded by the y-axis, the normal to the curve, and the tangent. So now we are talking about the normal to the curve where x is equals to 1, the tangent to the curve where x is equals to -1, and it's also bounded by the y-axis. Find the area of the triangle. That's a nice question. Find the area of the triangle. Give your answer correct to 3SF for 8 marks. This is 8 marks. That's a lot. And this is 5 marks. That's a lot. 13 mark. So now focus on this. One single question and 13 marks for question number 11 out of maximum 75 marks for the whole paper, for the whole P1 paper. So that's a lot. So now let's look at the working without further ado. That is over here. Now look at the working. Let me make you go through it. First thing, write it properly. No compromise on that. So this is, let me reduce the brightness. Okay. This is 4x negative 3. This negative remains as it is, 3x negative 1. And this plus 2 as it is. Differentiate. Take the power down. X remains as it is. Power reduces by 1. Minus 3 as it is. Minus 1 comes down. X minus 2. Derivative of a constant is 0. And then simplify. Then simplify. And then I took common. I took 1 over x square common. So this is what you're getting. I also took that 3 common out. So you can do it in steps. You can do it in one shot. No issue. Now, decreasing f prime x is greater than 0, 3 over x square. And this thing in bracket is less than 0. Now, 3 over x square has no solution. Why? Because the variable will disappear. So just solve this particular part. Minus 4 over x square plus 1 is lesser than 0. Minus 4 over x square is lesser than -1. Minus 4 is lesser than minus x square. You get a quadratic inequality. This is x square minus 4, which is x plus 2. X minus 2 is lesser than 0. Factorization is a must. Draw a small sketch. Mark the roots. Lesser means region below the x-axis. One single region, one single inequality. That is the answer. Now over here, we should also write x should not equal to 0 because it says so. X should not equal to 0. Another approach is that I take the LCM. I write f prime x is lesser than 0. This is without taking common. And then we end up with the same answer. So don't forget to write this thing. All good, all clear? That is part A. That was a tough question. Now it says a triangle is bounded by the y-axis, the normal to the curve at the point where x is equals to 1, and tangent to the curve where x is equals to negative 1. So now, first of all, you already have the derivative. I'm just readjusting things. And let me just set up my mic over here. So now over here, it says find the area of the triangle. Now, first of all, f prime x is given. When x is equals to 1, f prime of 1 is negative 9. Gradient of tangent, negative 9. Gradient of normal, positive 1 over 9. When I plug in 1, the y coordinate, that is over here, is 3. When I plug in negative 1, the y coordinate is 1. So for normal, the coordinate is 1 comma 3. That is the gradient. Y minus 3 is 1 over 9, x minus 1. For tangent, if I plug in f prime minus 1 in f prime, I get negative 9. That is gradient of tangent. That is the point. So now it's not difficult. It's elaborate working. Maybe when you join everything, that might be difficult. But right now, this is what it is. This is the equation of normal. This is the equation of tangent. Line meets y-axis. Therefore, x coordinate is 0. So no need to expand. First, make x coordinate equal to 0. You get y as 26 over 9. Similarly, also over here, x is equals to 0. You get y as negative 8. Now it says blue line meets the green line. Where does it say that? A triangle is bounded by the y-axis, the normal to the curve at the point where x is equals to 1, the tangent to the curve at the point where x is equals to negative 1. Find the area of the triangle. So that means you have this curve, something like this. There is a tangent. There is a normal. So you are looking for this point, and this point. Got the idea? Something like this. Blue line meets the green line. That is the expanded form of the blue line. That is the expanded form of the green line. So hold for a second. Let me just focus on the green line. So the blue line is this thing. So let me change the color to blue. The green line is like this. Let me change the color to green. And over here, these are the two lines that you have. Got it? So now that is the blue line. This one over here, that is the blue line. That is the green line. You solve simultaneously. So now solve simultaneously. So when you solve simultaneously, what do we get? We get x as this and y as this. Now over here, this is this value, x is this, y is simplified, which I did not, I think. Okay, so now it says, hold for a second, let me remove it. Now look at the values. The y-intercept was this thing, 0, 26 over 9. X coordinate is 0, y coordinate is 26 over 9. X coordinate is 0, y coordinate is minus 8. That is below the x-axis. It's not drawn to scale. And I don't need the y coordinate. I only need the x coordinate. That is 49 over 41. That is over here. So these are the 3 points that I am interested in. This is where the tangents are meeting each other. So the tangents are meeting each other. Let me change the color. This one is one of the thing. Let's say that's the blue one. Let's say that is the green one. Doesn't make a difference which one I label as which. And that is how they are meeting. So now the base is this thing. 26 over 9 minus 8. That is this thing. And the height is this thing. That is 49 over 41. Simplify, you get this answer. Of course, you can also use that formula. That is area of triangle. That is half x1, x2, x3, x1, y1, y2, y3, y1, and then you know exactly what to do. You multiply in this direction and add it up, something like this. You multiply in this direction and then add it up, and then there is a minus sign and things like that. So yes, this was a very tough question, especially the last part. Got the idea? That is the area of a triangle based upon this. So now this thing was again differentiation plus basic geometry. That is the logic over here. Let's move on. Now let me look at this paper, May, June 2024, variant 1, 2, and let me focus on this thing. Okay, a question about maxima, minima. Let's read the question first. It says the curve with the equation has a minimum point at A and intersect the positive x-axis at B. Again, it's an elaborate question. Find the coordinates of A and B. And then it says something to do with area under the curve. Okay, so it's differentiation and integration. First of all, let me focus on this thing. This is y. This it's already written properly. dy by dx. dy by dx equals to 0. Minima, maxima, it's a turning point. You get x is equals to 4. You get y is equals to negative a. So that's the coordinate of a. Intersects the positive x-axis at b. Y coordinate is 0. You solve this equation. This is not a disguised quadratic equation because you can take common out. So I wrote x as root x, root x. I took 2 common. I took root x common. And this is what I get. X is equals to 0. This is not positive x-axis. That's the origin. And this is x is 16. So therefore y is 0 and 16 comma 0. That is the answer for this thing. Okay, I don't know why I calculated y because I took y and then that was already 0. So there was no need of this thing. All good. So let me just erase this thing. So sometimes you are in a hurry and you do something that is not even required. Okay, so B is 16, 0 for 4 marks. Now it says, let me add a page so you can analyze the question first. Now look at this question. Sometimes when it's below the x-axis and it's tilted this way, so of course you have the liberty of flipping the question around. So now what I do is that since I don't have the liberty of turning it around, so what I can do is that I can take a screenshot. I can save this image and then let me paste this image over here by turning it upside down. Okay, so just to give you the idea. So now over here, what do we see? We see that between these 2 points, that is the area under the curve, that will include everything, and subtract from it area of triangle, that will give me area of shaded region. Okay, so now let's double check. First of all, this is the equation of the curve. Equation of AB is already given. Find the area of shaded region. If I plug in 4, I'll get negative 8. If I plug in 16, I'll get 0. Now, how can I get this thing? If I make y equals to 0, therefore 2x minus 32 equals to 0 because this constant disappears. Therefore, x is 60. If I plug in 4, I get minus 8. So 4 till 16, that is 12 units. And this is 8 units. You take the positive value, that comes out to be 48 square units. Area under the curve is between 4 and 16. So this is simple integration. You plug in 4 and 16. You should know indices. 16 raised to power of 3 over 2. That is 4 square raised to power of 3 over 2. 2 cancel. 4 cube is 64. 4 raised to power of 3 over 2, that is 2 square raised to power of 3 over 2. 2 cube comes out to be 8. Now you evaluate. Definitely you will be getting a negative answer because it's below the x-axis. So you discard the negative sign. It's a sign. It's a sign, S-I-G-N. It's a sign that you did it correctly because the answer is coming out to be negative because the area is below the x-axis. Now from this area under the curve, subtract the area under the line, and therefore that is the answer of the shaded region. Now similarly, let me choose another question. Again, increasing, decreasing. I think this is pretty basic. A function is such that f prime x is this. Determine the set of values of x for which fx is decreasing. So fx is less than 0. This thing lesser than 0. Now I cannot solve. No, this is important in the sense that I cannot solve things as it is. Let me add a pink page over here. So over here, the special thing is first expand, then simplify. Because before that, you cannot proceed with the inequality. You have to solve this inequality. So again, you have a middle term factorization. You get the factorized form. You have the factorized form, and then it's lesser. So it's the region below the x-axis, one single region, one single answer. X lies between these two values. All good? Given that f of 1 is negative 1, that means when x is 1, therefore the y value is negative 1. This is the coordinate through which it's passing. So now it's about integration. So what we do is that we integrate the function. This is chain rule. This is basic. 6 was common. That's why I took common. Otherwise, don't be obsessed with taking common. So now 6 is there. This is application of chain rule. You have C. You plug in X and Y. You find the value of C. You write down the equation. So in the next paper, that is May, June 2024, variant 1, 2. Which one did I focus on? I think I focused on integration, area under curve, and I focused on this thing that is again decreasing. And then I did gradient function becoming a equation of curve. So these are the different things that I focused on. All got all clear? Now, rates of change. Yes, it's good that we should be talking about rates of change also. Read the question first. It says the equation of a curve is this much. A point P is moving along the curve in such a way that the y coordinate of point P is decreasing at a rate of 5 units per second. So when they say increasing, you put a plus sign. When they say decreasing, you put a negative sign. Find the rate at which the x coordinate of point P is increasing when y is 32. Step 1. That is when y is 32. You plug it in over here. You do the subtraction. And this is 5 minus 2x raised to power of 3 over 2. Now, O-level math basics. It's so important that it strikes every way. And indices was considered a simple chapter, but its application, it is simple, but its application, you have to be very, very vigilant. So now over here, what do? We have this thing. Hold for a second. So now what do? We have this thing. And if it says a raised to power of m, if it equals to b, therefore a is b raised to power of 1 over m. You raise the other side to the reciprocal power. This power is 3 over 2. So if I want to remove this, I raise it to the power of 2/3. I raise it to the power of 2/3. 27 raised to power of 2/3 becomes 9. That's working us right over here. 27 is 3 cube. 3 3 cancel, 3 square becomes 9. 5 minus 2x is 9. Therefore, x is negative 2. All good, all clear? So now over here, step 1 is there. Step 2, differentiate. Plug in the value of x is equals to negative 2. This thing goes over here. That is dy by dx. Step 3, related rates of change. Y, x, and t. How are they related? Dy by dt equals to dy by dx into dx by dt. Dy by dt is negative 5. That is given at the beginning of the question. Dy by dx, just evaluate it. Dx by dt, that becomes the subject. Yes, it's coming out to be positive. That means, yes, it is increasing at this rate. I hope everyone got the idea loud and clear. So rates of change, I hope this is all good, all clear. Now we are starting. This one is the same as this. Yeah. Also read this thing. Acha ji. I'm just looking at this. Okay. So now it says point A on the curve has y coordinate 32. Isn't that the same thing as this? Yeah, this is the same one. That means the x coordinate will be minus 2. Find the equation of the perpendicular bisector of AB. Give your answer in the form such and such, where ABC are integers, and this is for 6 mark. Point B, dy by dx is negative 3. That is also evaluated. So be very, very vigilant what you have done. So x is minus 2, and the gradient of the curve, gradient of the curve is also given. Point B is different, point A is different. So point B, we are looking for this perpendicular bisector. So now for point B, what do I need? I need to find the x coordinate. That was missing. So dy by dx is this, equate, you get x is equals to 2, you find the corresponding y coordinate. So this is 2, this is 6, and a was given from part 1, which is minus 2 and 32. Then you find the equation, then you find the gradient of AB. You find the gradient of perpendicular bisector. This is negative reciprocal. You find the midpoint, and then you find the equation of a line, and then you write it in the proper format. All good, all clear? So now look at this. Uh, People say that they don't ask a separate question on coordinate geometry. Here it is. Which year it is? This is May, June 2024, variant 1, 2. So they have linked differentiation with coordinate geometry. And for point B, the gradient was given, and we equate. You find the x coordinate, then you find the y coordinate, then you find the gradient of AB. A is the same point as before. Then you find the midpoint, then you find perpendicular bisector. So how basic could you expect around this? Let me move on. Okay, Ji. Let me just write something on this thing. So remember, this thing was very nice. That is that May, June 2024, variant 1.1, variant 1.2. This needs your attention a lot. Jot down the important details separately on a summary sheet. Acha ji. So rates of change is done. Now we are going May, June 2024, variant 1.3. अच्छा जी, आगे बढ़ते हैं. Binomial skip. Another basic question, but we should not skip it. Okay, now let's have a look. Let me get my glasses. It says the equation of a curve is y equals to 2x squared minus 1 over 2x. So now keep in mind, minus 1 over 2 remains as it is, x raised to power of negative 1. So make sure that you write it properly. Plus 3, find the coordinates of the stationary point. So y is this thing, dy by dx is this thing. Again, simplify, differentiate and simplify, differentiate and simplify. For some things, first simplify, then differentiate. Stationary point, dy by dx is 0. Cube root of a negative number exists. Plug in the original equation. That's the equation of the curve. You find the y coordinate. And this is what we get. Determine the nature, dy by dx. You differentiate it again. And then you plug in x is equals to negative half. This is coming out to be positive. It's a minimum. I'll just pause for Azan. So now people, let's look at part B. Determine the nature, that thing is done. Second derivative is positive, it means a minimum. Second derivative is negative, it means a maximum. For positive values of x, determine whether the curve shows a function that is increasing, decreasing, or neither. Give a reason for your answer. Dy by dx is this thing. If x is positive, 4x will be positive. X square will be positive. There is a positive sign in the middle. Therefore, dy by dx will always be positive. Therefore, the function will always be an increasing function. This thing is done. So first thing was about stationary points and increasing, decreasing. Second question, you can have a look. So this is increasing, decreasing function and stationary points. And now it's about integration, I think. And what else is there? Transformation, no, we are not. We are just focusing on integration. A curve passes through the point. Let me put a highlighter over here. A curve passes through the point and is such that dy by dx is this much. Take it up, integrate according to chain rule of integration. Increase the power by 1, divide by the new power, divide by the coefficient of x, simplify. How do you evaluate? Plus c, you plug in x, you plug in y. You plug in x, you plug in y. You plug in x and y, you find the value of c, and that is the equation of the curve. Now, over here, okay, now this looks like equation of tangent and volume. Have a good look. Read the question first. And integration, I think that is area or volume. Area slash volume of revolution. Now it says the diagram shows a curve with the equation such and such. Find the equation of tangent to the curve at the point where x is equals to 3. Give your answer in the form ax plus by plus c is equals to 0. Y is this thing, power of half. Differentiate. Half comes down, bracket remains as it is, power reduces by 1. Don't forget to multiply by derivative of bracket. Simplify, the 6 and 2 cancels out, and this is what you have. The tangent is at x is equals to 3. Plug in x is equals to 3. Simplify, you get this thing. And this is the corresponding y coordinate. That is the gradient of the tangent. You have x, you have y, you have gradient, you write it. Since they have asked us to write in this format, you have to expand the whole thing. 27x minus 8y minus 17 equals to 0. Some people, they ask this question. What if I wrote negative 27x plus 8y plus 17 equals to 0? This is also good, also clear. The second part, that is about volume. The region is enclosed by the curve and the straight line x is equals to 1, x is equals to 3. So this is simple volume and this is around or about x-axis. Find the volume of solid obtained. Sometimes they use the word generated. When the shaded region is rotated 360 degrees about the x-axis, it's always 360 degrees. Yes, if someone is obsessed with radians, they can write 2 pi radians about x-axis. They can write one complete revolution around x-axis. They can write 4 right angles around x-axis. So 360 degrees, 2 pi radians, one complete revolution, 4 right angles. Over here, we will only have a pi. Don't forget to square it. So in the first step, simply square, no matter how simple it looks. Do not jump. So now this is power 1. Of course, chain rule is not applicable. Chain rule is n slash a not applicable. Why? Because this is non-linear. This is not a linear expression. As simple as this. Integrate it individually. Plug in the limits. Simplify. You get the answer. Leave the answer in terms of pi. Don't forget to write cubic units. Okay, this is completing square. Ignore it. Ignore it. Let's move to the next paper. So now this is October, November 2024. This looks like a nice question. Have a look. I'll just write the details in the WhatsApp group. October, November 2024, variant 1, 2. Now it says the curve y is equals to such and such has a stationary point. So first of all, take this thing up at minus 3b. So now these are the two conditions that you have. When x is minus 3, y is b. So when x is minus 3, y is b, that is the first one. That goes in the original equation. And the second one, when x is minus 3, y prime is 0. So when x is minus 3, y prime is 0, that goes over here. Got the idea? So this goes in the original equation of curve. This goes in first derivative. So be very, very clear what belongs where. So over here, you write y as b, you write x as negative 3. Let me highlight it further. So y is b, this is negative 3, this is negative 3, and you have this first equation over here. Similarly, you differentiate it. Hold for a second. You differentiate. After differentiation, then you plug in y prime as 0 because it's a stationary point. You plug in the x coordinate, and what do? We find the value of a. Once we find the value of a, we can then find the value of b. So basic, straightforward, nothing special. This is something else. Okay. Let's have a look. The equation of a curve is dy by dx is this much. Find the x coordinate of the point on the curve at which the gradient is 11 over 2. Gradient function is there. Dy by dx is 11 over 2. Solve. And what do we have this time? We have a disguised quadratic equation. Knowledge of quadratics is assumed in differentiation. So disguised quadratic equation is used up in differentiation. It's their creativity where they want to use it. So let m is equals to root x, m square is x. You solve, you find values of m, but remember what is m? M is root x. So root x is 3 over 2, x is 9 over 4. Root x is negative 3 over 4, x is 9 over 16. Does it say any limitation? So now find the x coordinate at which the gradient is 11 over 2. Hold for a second, my bad. So now, why am I rejecting it? Let's think about it a bit later. So now it says, given that the curve passes through the point 411, find the equation of the curve. Now integration, integrate each term, simplify, indices, lots of indices. Then you plug in x is 4, y is 11, and you find the value of c as -9. Now, the question is, they are asking us the x coordinate of the point at which the gradient is 11/2. So now we are getting two values, 9/4, 9/16. I think the only rationale or the reason is you can plug it in over here and double check. So if I plug in 4 into 9/4 minus 3 into square root of 9/4 is 3/2 plus 1. So this 4 will cancel out. We are left with 9. And then 3 into 3/2 plus 1. So that is 9/2. And this is 4. So 4 plus 1 is 5. 5 plus 9/2. 4 plus 4.5. This is 8.5. And that is one of them is giving me the right answer. The other one will not be giving me the right answer. So that is the logic. And let me also go to the examiner report. This is question number 5. You have to check it by plugging in. Now hold for a second. Where is it? This is question 5. Let me just double check. Differentiate. Okay, now it says obtain x is 9/4 or 9/16. X is equals to 9/4. X is 9/16. No method for solving three-term quadratic. No method. They did not specify it very much. Let me see if the examiner report is not here. So this I have to look, because as such there seems to be no rationale for ignoring this thing as such. So that was question number 5, I think. Now let me add a page and let me just write this equation. This is 4x minus 3 root x plus 1. X is 9/4. X is 9/16. Square root of 9/4. Let me write this thing as 3/2. Square root of 9/16. Let me write this thing as 3/4. Let me use this thing. So therefore, this is dy by dx. Therefore, dy by dx is 4 into 9/4. Is it 9/4? Yeah, 9/4 and 9/16. 9/4 minus 3 root x, 3 into 3/2 plus 1. And over here, dy by dx is equals to 4 into 9/16 minus 3 root x is 3/4 plus 1. Now let's simplify. This is 9. This is plus 1 minus 3, 9/2. So this is 10 minus 9/2. This is 20 minus 9/2, which is 11/2. What about this? This is 4 ones are, 4 fours are. This is 9/4 minus 9/4 plus 1. This comes out to be 1. So this one is giving me the correct answer for gradient. This is some wrong solution that came out. So reject. And this one is accept. So that is the logic behind it, which the examiner did not touch very seriously. So now this one, I think this is also straightforward, nothing special. This is trigonometry. We have to look for it. Quadratics, AP, GP. This is function. And let me also go to the other two papers quickly. So this is October, November 2024, 1, 2. Yes, let's have a look. This is again first principle of differentiation. It says the equation of a curve is this. 2 points with x coordinates 2 and 2 plus h respectively lie on the curve. Find and simplify an expression for the gradient of the chord AB in terms of h. When x is 2, y is 5. When x is 2 plus h, y is this thing. So this is A, this is B, this is A, this is B. Just find the gradient. So the gradient is coming out to be this. That is the concept of that first principle, the chord thing. Explain how the gradient of the curve at the point A can be deduced from the answer to part A and state the value of the gradient. When A and B are very, very close, change in x is almost negligible. That means h goes towards 0. So if gradient is this much, the difference between 2 and 2 plus h, that's a very $1,000,000 question. The difference between 2 and 2 plus h, this difference is h. If this is very, very close, this is almost negligible. So negligible that it will become 0. So all you have to do is that gradient expression, remove the h. So 2 into 4 is 8. That's the value of the gradient. So now this was one nice question. What else was there? Something different, something strange. Okay, now again, area under graph. The first one is about completed square method. The second one is the diagram shows part of the curve and the line with the equation such and such. Find the area of the shaded region. So between these two values, find the area under the graph and then find the area of this trapezium. Remember, it's not a triangle because there is a height over here. So now this is a trapezium, subtract. So now over here, first of all, we solve it simultaneously and we get two values, x is -1, x is +1, x is -1, x is +1. That is the trapezium. The y coordinate is 1, the y coordinate is 17. You can find the area of the trapezium. Also, you can find the area under the curve. I have used the completed square form. According to chain rule, basic integration, plug in the limits, simplify, you get this thing. The difference between is the area of shaded region. That comes out to be 2 2/3 or 8 over 3. And this one was one tough paper, especially from the perspective of quadratics. And I think the last one is this thing, 1 3. Let me just go over the differentiation integration questions. Okay, now look at this one. The diagram shows the curves with equations such and such. Find the x coordinate of the points of intersection of the curve. Now there are 3 points of intersection. So it's a cubic equation initially, but when you simplify, you can take the x common out and you get a quadratic equation. So one of the solution is 0. The other two solutions are over here. So one is 0, the other one is 1, the third one is 3. Now they're asking, probably asking for the area between these two curves. So that is between the limits, integrate both curves between the limits 1 and 2, 1 and 3. That's the first curve integrated between 1 and 3. Second curve integrated between 1 and 3. Area of shaded is the difference. So what I did is that instead of first plugging in the values after integration, these two have similar terms. So why shouldn't I simplify the terms and then do the subtraction? I think that's very worthwhile. And I think I left it in the middle. That is basic arithmetic. You can handle it definitely. And the last question, the equation of a curve is this much, where k is a constant. Find the first derivative. It's in terms of an unknown constant. Find the second derivative. Again, it's indices. It is given that k is equals to 2. Find the coordinates of the stationary point. So k is equals to 2. So if I plug in k is equals to 2 over here, so therefore 2 and half would cancel out. I'm left with x raised to power of -½ minus 8x. I have plugged in over here, but I did not show. So let me write it over here. When k is 2, dy by dx is half into 2 into x minus half minus 8x. That is x minus half minus 8x. So this is the one. And then coordinates of stationary point, dy by dx equals to 0. And you are getting x is 1/4. You can also find the corresponding y coordinate. When x is 1/4, y coordinate is 11 over 4. And at this thing, the double derivative is negative. How do I plug it in? You just plug it in over here. The double derivative is coming out to be negative. And then it says point A and B on the curve has x coordinates such and such respectively for a different value of k. The tangents meet at point with x coordinate 0.6. Now, this is one nice question. What we do is that when x is 1/4, y is this much. It's in terms of k because it says for a different value of k, do not use the previous value. When x is equals to 1, y is this. dy by dx is this, dy by dx is this. Now you write the equation in terms of k, equation y minus y1 mx minus x1, y minus y1 mx minus x1. You simplify and you plug in the x coordinate 0.6. You solve, both sides are equal. This is y, make them equal. And you can, without making the subject, the y will eventually cancel out. So just plug in x is equals to 0.6, you'll find the corresponding value of x, which is 3. So I think that is overview of 6 variants of May, June 2024 for differentiation and integration. So this is all done and dusted. See you in the next class.